Good morning, everybody, and happy hump day. Welcome to day 6 of the AP Calculus free response question advent calendar. Let's find the 6th chocolate on this chocolate calendar. Oh, there it is right there with the squirrel here at the top. And then we'll jump into some calculus. I'll zoom in there. You can get a good look. Look at that squirrel and his bushy tail. He's looking at his squirrel friend here. They both have acorns, but the acorns actually look like bowls of beans, which is an interesting thing. But anyway, let's get into this chocolate. As I open up the slot, I'll go ahead and put today's question on screen now so you can start reading it while I dilly-dally with these candies. We're doing a related rates problem today. Deals with pots of coffee. I love coffee, and ooh, I love these rectangular chocolates. Look at that. Oh man, it's so shiny. It's so rectangular. I'm so excited to have this chocolate. Almost as excited as I am to do this calculus problem. And for Christmas, I really got to finish up my Christmas shopping. You probably do too. Golly gee willikers. Dang, that hits the spot. You know, I'm getting used to this routine of having chocolates first thing in the morning. Probably not a good habit. What is a good habit, though, is always doing calculus. So let's do some of that. This is problem 5 from the 2003 AP Calc AB exam. Let's read it. A coffee pot has the shape of a cylinder with radius 5 inches, which we see here. Let h be the depth of the coffee in the pot, which is also measured in inches. H is a function of time measured in seconds. The volume, V, of coffee in the pot is changing at the rate of negative 5 pi root h cubic inches per second. So the volume of coffee in the pot is decreasing. Coffee is leaving the pot, and thus the height of the coffee is going to be decreasing as well. Part A is to show that the height of the coffee is changing with respect to time in this way, negative root h over 5. So we just need to find dh dt. We can do that using the volume of a cylinder equation, which is given to us. V equals pi r squared h. The cylinder we're thinking about is this cylinder of coffee inside the cylindrical coffee pot. If we take the derivative of the left side of the volume equation with respect to t, we're going to get dv dt, which is going to work out just great because dv dt was given to us. We know that dv dt equals negative 5 pi root h. So let's go ahead and write that. dv dt, we know, is negative 5 pi root h. All right, now I'm going to rewrite the volume equation. Volume equals pi r squared h, and we can go ahead and take the derivative of both sides. Remember that on the right, the only function is h. Pi is a constant, and r is a constant as well. The radius of the body of coffee is going to be 5 inches, the radius of the containing cylinder. Even as coffee leaves the pot, that radius is not going to change. All right, so taking the derivative on the left with respect to time, we get dv dt. On the right, r squared is 5 squared because the radius is fixed at 5. So this is just going to be 25 pi multiplied by taking the derivative dh dt. Now we're trying to solve for dh dt. We know what dv dt is, so let's replace dv dt with its given value, which is negative 5 pi root h. Now we'll just divide both sides of this equation by 25 pi in order to solve for dh dt. And I'm going to write dh dt on the left. So this will be equal to this divided by 25 pi. And when we divide by 25 pi, 5 over 25 just leaves a factor of 5 in the denominator. The pi's cancel out, and of course we still have that negative. And thus we see that dh dt equals negative root h over 5, just as desired. So we can move on to part B. Given that h equals 17 at time t equals 0, we want to solve this differential equation for h as a function of t. So this is actually a separation of variables differential equation question. We need to separate the h's, we'll move the h's to the left, and separate the t's, get those to the right. Then integrate both sides of that equation and use this initial condition in order to solve for the arbitrary constant. So let's start setting this up, and I'll write it in red. We're going to take this equation, divide both sides by root h, and multiply both sides by dt. Thus, we're going to have 1 over root h dh on the left, and on the right, we're going to have negative 1/5 dt. Now, 1 over root h is the same as h to the negative half, so I'm just going to write it like that because that's easier to integrate. Now we integrate the left side, and we integrate the right side. On the left, using the reverse power rule to integrate this function, we increase the power of negative half by 1. Thus, it becomes a power of positive half. And then we divide by this new power. Dividing by a half is the same as multiplying by 2. In theory, we also have to add an arbitrary constant, but that's going to happen on the right side as well. So let's just gather the arbitrary constants on the right side. This is going to equal the integral of negative 1/5, which with respect to t, which is just negative 1/5 t. And then we have all our arbitrary constants. We'll just call that a plus c. So how do we find h as a function of t? Well, first, let's use our initial condition in order to solve for c, the arbitrary constant. The initial condition is that when t equals 0, h is 17. So let's plug that in. We have 2 multiplied by 17 to the 1/2, which is the square root of 17, equals negative 1/5 times t, but we're plugging in 0 for t, so that's just 0, and this equals c. So there we go. That's the arbitrary constant. It's 2 times the square root of 17. So I guess we'll just go ahead and replace that c right now. Let's write this as plus 2 times the square root of 17. And then I'll move this equation off to the side. We don't really need that anymore. Now all that's left for us to do is to solve for h. To do that, we'll divide both sides of this equation by 2 and then square both sides of the equation. Dividing both sides by 2 turns negative 1/5 t into negative 1/10 t, and 2 root 17 becomes just root 17. And then we would square both sides to get rid of that exponent of 1/2. And thus, we have our function for h in terms of t. H equals negative 1/10 t plus the square root of 17, all squared. And we're in luck because we can very easily use our solution to part B to answer part C. Part C asks, at what time t is the coffee pot empty? Well, the coffee pot would be empty when the height reaches 0. That would mean that the coffee is all the way at the bottom. There is no coffee. When the height is 0, that's when there's no coffee. So we need to come to this equation and plug in 0 for h and then solve for t. Now, if we plug in 0 for h, I'll write that this is part C. If we plug in 0 for h, we have that 0 equals this thing squared. But if 0 equals something squared, then 0 must just equal that something. So 0 equals negative 1/10 t plus the square root of 17. Again, we need this to be 0 because we need the height to be 0, because that represents there being no coffee in the pot. And then we just solve this equation for t. So we'll subtract root 17 from both sides. So we have negative root 17 equals negative 1/10 t. And then multiply both sides by negative 10 to finish getting t by itself. Thus, we have that t equals 10 times the square root of 17. And that is when the coffee pot is empty, after about 10 times the square root of 17 seconds. And that completes our solution. to problem 5 from the 2003 AP Calc AB exam. Let me know in the comments if you have any questions, and I hope you're enjoying the AP Calculus Free Response Question Advent Calendar. There's a link in the description to the full playlist, as well as a PDF of all the problems we're going to be solving this December, so make sure to check those out if you haven't already. I'll see you tomorrow for another free response question. Thanks for watching.